Here we have a problem with a lot of moving parts. We have the position function for a rock, and we're trying to figure out its velocity after rising 12 feet. In order to get the velocity of a function from its position function, you take the derivative. So here we have position velocity will be h prime of t equals 5 minus t. That is the derivative of this function. Now the next problem is we want to figure out the velocity after rising 12 feet. This is not a unit of time. 12 feet is not the number you're going to plug into this. Then you might think, well, why not? Well, t is a time, so we're looking for something like 3 seconds or 5 seconds or 10 seconds, not 12 feet. So this is not the number that goes in here. Well, how do I figure out the number that goes in here? We're going to take this number and set it equal to the position. After all, this is the position. After rising 12 feet, after the rock is at a height of 12 feet, we're going to figure out the time that corresponds to that height. So we're going to set this set the position equal to 12 and solve. I'm going to go ahead and rewrite this a little bit. I'm going to multiply both sides by 2 and then shuffle some terms around. This is going to give me t squared minus 10t plus 24 equals 0. Now that I have rearranged that equation, I can go ahead and factor this into t minus 6 and t minus 4. So there are 2 points for which this particle, this rock, has a height of 12 feet, which makes sense because, after all, presumably this rock is a parabolic motion. So there's a height of 12 here, and there's a height of 12 here. So it reaches a height of 12 at one point, and then comes back down and reaches another height of 12. We're going to use t equals 4 because we're trying to figure out the time where it first reaches 12 feet. So t equals 4 is going to be the magic number we plug into this function. So we're going to say h prime of 4 equals 5 minus 4, which is 1.